welcome to my channel, and in today's topic we're gonna learn about Abg interpretation. Alright, so in Abg, as we talk about Abg interpretation, it will be very helpful in your clinical practices for nurses, alright, and also for some of the students who are studying in the nursing colleges or your nursing school. Alright, so talking about Abg interpretation. Abg interpretation. By by saying Abg, four main diagnoses can be framed out easily by interpreting an Abg or by seeing an Abg report. Alright, so this four main diagnoses are, which you can frame out by looking after an Abg report, are respiratory acidosis, respiratory alkalosis, metabolic acidosis, and metabolic alkalosis. Alright, so this four main diagnoses can be framed out by seeing an Abg report or after interpreting an Abg, or you can interpret this four main diagnoses by seeing an Abg report. Other diagnoses can also be framed out, but these are the four basic main diagnoses. So to interpret an Abg, whenever you look after an Abg report, the first thing you need to look after is your blood pH. Alright, so the normal range of blood pH is from 7.35 to 7.45. Alright, so there could be some of the changes happening inside our body, alright, which may alter the pH of our body. So when this happens, or when the pH goes below 7.35, then our body goes into the state of acidic. Alright, there may be instance where our body's pH may move upward from 7.35. So if it does so, then our body will be moving into the state of alkaline. So by this, just seeing the pH, we will be able to identify whether our body is in acidic or in the alkaline state. So if it goes, the value goes below 7.35, so it is acidic in nature, and if it goes above 7.45, then it is alkaline in nature. The next thing you see in Abg is your CO2. Alright, I'll write here CO2. Alright, the next thing you'll see after pH is your CO2, which is carbon dioxide. For carbon dioxide, there is a normal range from 35 to 45. Alright, so after that, the other value that you'll be looking after is your bicarbonate, which is HCO3, and its normal range is from 22 to 26. So by seeing this three only, you can frame out these four major diagnosis. To frame these four diagnoses, one important formula which you need to know to interpret an Abg is your ROME. R-O-M-E, ROME. ROME simply means respiratory is always opposite and metabolic is always equal. Alright, respiratory is always opposite, metabolic is always equal. You will be confused what does this term mean, so we'll be solving this out. Alright, so whenever we are talking about respiratory will be referring to our CO2, which is carbon dioxide, and we should know its normal range, which is from 35 to 45. And just similar to pH, whenever we see the Abg of our patients, we can see the values moving downward below 35, or sometimes moving upward from 45. Similarly, here when we are talking about metabolic, we are referring to HCO3 or bicarbonate. For this also we need to know its normal value, which is from 22 to 26. There may be an instance where the value can move downward below 22, or it can move upward above 26. So here to apply the formula of Rome, take an example. Take for instance, you saw a report or you get a report where you see the pH of a patient is 7.22, which means that here the normal range is 7.35 to 7.45. So here when you see, it is moving downward from your normal range. Alright. So next what you'll see in your ABG is you'll see after CO2. To meet the formula of Rome, which means respiratory is always opposite. Now here, because the pH is going downward, so to meet the formula of Rome, because respiratory is always opposite, pH is moving down, so your CO2 needs to move upward. Upward than the normal range, which is 35 to 45, it needs to move upward than your 45. Take for instance here, the CO2 is 50. So whenever you see the value here, because the pH is moving downward, the CO2 needs to move upward to meet the formula of Rome, which means respiratory is always opposite. And here it is being met. So to frame this diagram, how do you frame? Because it is moving downward, therefore it is acidic, and because you are seeing CO2 and your Rome formula is been met, therefore CO2 will be referring to your respiratory or respiration, which directly means respiratory acidosis. So our first diagnosis has been made by the formula Rome. Alright. So whenever you are seeing, what do we learn by respiration is whenever you see CO2, if your pH goes down, your CO2 needs to go up. Or if your pH goes up, your CO2 needs to go down. We will see that in our next example here for the respiration. For example, if your pH goes above your normal range, that means above 7.45. Take for instance, if your pH is 7.50, which is going above your normal range. So next you'll see after your CO2, to meet the formula of Rome, because the pH is moving upward, your CO2 needs to go downward. Downward meaningly it needs to go down or below your normal range, that is below 35. Take for instance here the CO2 value is 20. So when you see here, because the pH is moving upward, the CO2 is going downward. Alright, not because of the pH, but to meet the formula of Rome, pH is going upward, that means that CO2 needs to go downward, and yes, the CO2 is going downward. So to frame this diagnosis, because the pH is moving upward, that's why it is known as alkaline or as alkaline in state. So because we are seeing after CO2, so we can directly say it as respiratory or as respiration. So we can frame out respiratory alkalosis. Why alkalosis? Because it is moving upward than normal range. Alright. So respiratory alkalosis. So whenever you see here, the values are moving opposite to its own direction for CO2 or for carbon dioxide, where the Rome formula has been made, which says that respiration value is always opposite. If the pH goes downward, your CO2 will go up. Alright. If your pH is going up, your CO2 values will be going downward to meet the formula of Rome. Next we'll see for metabolic. Example 3, which is related to metabolic. Right. So whenever we talk about metabolic, so let's take an example. If your pH is, we'll take the same value. If the pH is goes below 7.35, which means 7.22, alright, which is going downward, you'll see, then come and look after your bicarbonate, which is HCO3. To meet the formula of Rome, which means metabolic is always equal, because your pH is moving downward, your bicarbonate also needs to go downward to meet the formula of Rome. Just to meet the formula of Rome, because your Rome formula says metabolic is always equal. So pH is going down, which means HCO3 also needs to go down. HCO3 value needs to go down down than 22, which is your normal range. Take for instance, its value is 18, which means that both the values are moving to same direction or equal direction. So for this, to frame this diagnosis, because the pH is moving downward, it is acidic. So because we are looking after bicarbonate, so we are referring to metabolic. So we can frame easily this diagnosis as metabolic acidosis. Metabolic acidosis. Alright? I hope you are getting my point. Next, the fourth diagnosis that we can frame out, we'll take the same example or the same value that we have taken here for pH. Here also we will take the same value. Take for instance, your pH moves upward than a normal in 7.45, which means 7.50, alright, which is moving upward than your normal range. So because your pH is moving upward than a normal range, to meet the formula of Rome for metabolic, so your HCO3, which is related to metabolic, now needs to go upward. Because the pH is going up, it needs to go up along with the pH to meet the formula of Me, ROME. Metabolic is always equal. So HCO3 also needs to move upward than its normal range, that is above 26. Take for instance, this value is at 30. Alright. So whenever we see the values, they are moving into the same direction or equal direction, which means metabolic is always equal. Alright. So to frame this diagnosis out, because the pH is moving upward, therefore it is alkaline in nature. Alright. So because we are looking after bicarbonate, therefore this can be called as metabolic. So we can easily frame another diagnosis as metabolic alkalosis. So this is framed as metabolic alkalosis. So as you can see, the common thing that we see in this four main diagnosis is, whenever we talked about respiratory here, the patterns were just opposite. The pattern were just opposite. If one was going up, another was going down. If one was going down, another was going up. Right? The values are always opposite when it comes to respiration or when it comes to CO2. But when it comes to metabolic, you see that the values are always similar, or the values are always equal. If one is going up, the other will also go up. Right? If another is going down, and the other one will also follow, and it will also follow it down only. So the values will be same. Right? So which is related to HCO3 or bicarbonate, and which is related to our metabolic. Alright. So to interpret an ABG, you can just apply the formula of Rome and frame out this four major diagnoses by just seeing an ABG report, which will be easy for your clinical practices. Alright. And you can alert your doctors too by seeing the report. So alright, so I'll be moving forward. If you see, sometimes there will be a situation where you see that the Rome formula is not been met. Alright. Sometimes there will be a situation, or there will be reports where Rome formula is not being made, which means that here in Rome formula we saw that the respiration is always opposite, which means if pH was going down, then your CO2 was going up. But sometimes the Rome formula will not be made. How? Meaningly, because the pH is going down, the CO2 has to go up to meet the formula of RO, respiration always opposite, and here it is being made. But sometimes what it does is pH is going down, CO2 will also come down than its normal range. Alright. Here we see the pH is going down, the CO2 is also going down, where the Rome formula has not been made. Similarly, when you see the bicarbonate value, HCO3 value, because the pH is going down according to the formula of Rome, here metabolic is always equal, the HCO3 need also to go down. But what it does is it does the opposite thing. It does not go down, the value does not go down, it goes upward than your normal range, which is 26. Let's take for instance here 30. So here, alright. So when you see this figure, here the Rome formula is not being met, alright. So here you cannot frame this for diagnosis. So what you will see or what you will tell in this kind of report, for this kind of report you can directly tell it as compensation. Alright. Whenever you see this kind of values where you are trying to meet the formula of Rome but your Rome formula is not been met, then you can say that the state or the body is on compensation, where one is compensating for another. Alright. So by this way you can easily frame out by seeing an ABG and by putting the formula of Rome, you can frame out 4 main diagnoses which is related to respiration and which is related to metabolic. And when your Rome formula does not meet, then you can directly tell it as your body is on compensation. Alright. So for compensation we will be talking about this in next video. So thank you so much guys for being with me in this video. I would like to request you all to please comment, like, subscribe, share, and help me out to grow with my channel. Thank you guys.